Hello everyone and welcome back. So in this video we're going to begin a discussion on normals, and we're having an issue with the default Unity generated normals that we are getting at the moment. And in this video Lee is going to demonstrate that to us, and then we'll move on from there into a better solution for handling normals ourselves.
Right. The nature of the problem has to do with the fact that we're using Unity's built-in recalculate normals method. Now, there's nothing wrong with it in of itself. And in fact, it does a very good job at quickly recalculating the normals of your mesh. The problem happens is the fact that it is optimized to calculate the normals or the vertex normals based on your mesh itself. If your entire object is made of a single mesh, it works great. Where we have a problem is if you have something like our terrain, which is made up of several terrain patches butted up against each other, where the edges of each individual mesh is, the recalculate normals doesn't know that there's an adjoining mesh with vertices and faces that it has to take into consideration. So what we end up with is a seam along those edges due to the fact that the normals are off, and the lighting calculation then has different information for each of the faces along that edge, which results in a visual seam. What we're going to be doing is looking at that problem in a way that we can work around it. Now, what I want to do is have a real quick and dirty overview of what normals are and the two types of normals that we care about. Particularly, we're only going to be calculating one because we're going to be cheating the way we do normals. But normally you would need to know face normals in addition, or the normals of a face, to be able to calculate a vertex normal. Now, what do I mean? If we look at, let's say I draw a edge, maybe, possibly, come on. Let's say this is the edge of a face, looking on it from the side.
So basically we're just taking a
triangle and
looking at it straight on the side. Okay.
Right. Now, a face normal is a unit vector, and it's doing it again. So let me try to draw this. That didn't work well. I'm trying to get a perpendicular. That was even worse. Don't mind me.
That's good enough.
That's better. All right. So let's say we've got a unit vector that is perpendicular to the surface of our face, pointed outward. A unit vector meaning that the direction, the magnitude of that vector is always going to be 1. Now, the way that is calculated is if we were to draw a triangle, we could calculate the plane of the triangle. Actually, it looks more like a pizza slice, but now I'm hungry. But we could look at each of the vertices. We could figure out what the plane is, calculate a normal that's perpendicular to that plane facing in a direction. Now, every face has the potential of having a normal pointed, in this case, out of the screen towards you or into the screen away from you. Now, what determines the direction of the normal is called the winding order of how you construct your triangle. So in this case, with a clockwise winding order, if we were to build our triangle starting in the upper left to our upper right down to the vertex in the middle, that would give us a clockwise winding order, which would result in a normal facing out of the screen or towards you. If we were to build it in a counterclockwise order, then the normal would be facing into the screen. And because I think almost all of the shaders that are built into Unity by default are single-sided shaders, anything that has a normal that's facing away from the camera is going to be called, and you won't see them. That's why when we've been playing with our terrain, if we rotate it underneath, once our mesh is generated correctly, we don't see anything. It completely disappears. It's only when we look at our mesh from the top that we actually see anything. So now that is a face normal. What we care about mostly our vertex normal. So if I were to draw one of, see if I can do this, one of our hexagons, and I were to divide it up. Why does this remind me of pizza?
Because you're getting hungry. We haven't had lunch yet.
Okay, let's pretend this was a point in the center.
Exactly.
But we've got 6 faces that surround any single point. Now, to calculate this vertex, so if we're looking at it at the side, same thing, but from the side. So this basically points to here. Come on. We've got points. It won't let me scribble. All right, but let's say we've got points at each side, and each one of these has a normal coming out of it. We want to calculate the vertex normal. If these are all unit vectors pointing straight up, we expect the vertex normal in the center to be straight up 1. But what happens if we have a normal that's off to this side over here? Maybe, so this one would be that normal. This one would be this normal. I'm fighting with it. So that's that normal. We've got another normal that is maybe facing out of the screen over here. And so we basically have each one of these faces has a different normal. It's a 3-dimensional terrain, so we don't expect everything to be perfectly flat. Mm-hmm. So everything's going to be slightly off. Well, the way normal calculations work is you take the vectors of each one of these, you do some fancy math, cross products, and then you end up with a vector that essentially is an average of everything else. It's not a perfect average because they are vectors and we have to do vector math to make it work. But what we end up with is the equivalent of some vector for each vertex that will correspond to the overall direction of the lighting would be for each one of these. Now, the way shaders work is we can take these normals for each one of these vertexes, and we can interpolate our lighting based on those normals across the surface of each face. That is what we're trying to get, is an accurate representation. Now, the problem that we get is if this is our mesh, and we have another mesh that is completely separate, and this is off to the side over here, then Unity doesn't know about it. So when it's calculating the contribution of all of these surrounding faces, it knows about this one and this face. So if I put little X's, it knows about this and this face when it's calculating the normals for these vertices. Can I circle it? Yeah, there we go. So when it's calculating the normals for these two vertices, it's calculating based off of any faces that are part or that are connected to that vertex. Mm-hmm. It doesn't know that there are other vertices around it. So the normals that we get are correct for that mesh, but not correct for the terrain altogether.
Right.
So we can go ahead and jump over into Unity, and let me swap out my graphic tablet for Unity. And if I run, I want to show what it's going to look like with our texture on it, because we're not going to see a whole lot. So if I go into our scene view, we jump back into perspective. The problem isn't really apparent, but that is because we've got such a high noise type of texture on it that we're not really going to pick up on it.
Oh, hang on one sec. I don't know.
Can you see it?
Yeah, a little bit.
Okay. Then it could also be part.
Right here.
But
I mean, there's actually several things that are contributing. But anyways, continue.
right. So if I pause this, then let's go ahead and check what our project settings are. So let's go to quality. This will help. Bump it up to fantastic quality. And then, so go to fantastic quality, go into our materials, and we're going to remove our texture itself. Let's hit none. Go ahead and hit play. So now you can see them. So let me also take our light. I think I set it at intensity of 0.5. Let's bump that down to, say, 0.25. So we're not blown out to white. Make it a little bit easier to see.
Mm-hmm.
So
there we go.
So now it's definitely easy to see.
Mm-hmm.
So what we do, or what we have, is the light is being calculated for each one of these individual patches based off of the normals of each of the faces that are surrounding each vertex. So this vertex has all of the information it needs for all the faces surrounding it, so we get accurate normal information. This point right here is missing two triangles that it needs. So the information that it gets is, 4/6 of the way there. So that's what, 4/6, 2/3. So it has 2/3 of the information it needs, but it's missing 1/3 of the overall information. So it's going to be slightly off. While this one has only 2/3. So our normals get calculated slightly different. Now there's another trick that we can do that we'll do inside of code. So if I go ahead and run in here, let's go back to our train patch inside of update. So I'm going to close all this down. Inside of update, let's go ahead and put in a visual clue so we can look and see what normals we're getting. So if I go in here, and we're going to do a for loop. Yeah, there we go. All right, now what we're going to look for is our mesh filter. So let's find our mesh filter, and we're going to look for its mesh, and we're going to get its vertex count. So we're going to loop through every vertex inside of our mesh filter. From there, what I want to do is draw a line. So we're going to do debug dot draw line, and let's go ahead and I'll put a var in. So we'll do var pos equals our mesh filter dot mesh. We're looking for our vertices with an index of I for its element. So we'll save that out. So that will give us a vector 3. We're going to draw a line from that position to that position. Oh, hold on. I also got to do one other thing. We'll come back and do that in a sec. And then we're going to add to the position our normal. So to get that normal will be mesh filter dot mesh. Whoops, didn't pick it up. So mesh filter dot mesh dot normals, and we're going to use I for the index again because the normal to vertice is a one-to-one relation. So we've got that saved out, and then I'm going to pick. Let's do yellow for our color. Now, this will work and draw our position. But if you remember from before, our vertices are saved relative to the mesh itself. So our mesh doesn't have holds our overall offset in the world, but our vertices are relative to that center origin, or the 0, 0.
Mm-hmm.
So if we want to move those in world position, we have to also offset by our position, which is a property that we created long ago, which calculates it calculates out the position of our overall mesh in the world. So we're adding the position of the mesh to the position of each vertex inside of the mesh, which will give us an accurate world location for drawing our lines.
Mm-hmm.
So if I build that out and go ahead and run. So hopefully we get yellow lines if I turn on the gizmos over here.
Oh, I think you got caught up in the actual player. There you go.
All right, so now we can see yellow lines being drawn in the direction of our mesh. So I'm going to switch over to the scene so I can zoom in. Now, if you look really, really close, yellow was probably a bad choice, wasn't it?
Yeah, I was thinking more like red on the grayish background.
Yeah.
A little easier to see.
Or even better, black. I picked yellow, and we will go back to yellow because I want to, when we get into the tangents and the binormals,
Mm-hmm.
I want to be able to demonstrate those relative to world positions.
Mm-hmm.
So I want to adjust that accordingly. So I want to use blue for Z and red for X,
Gotcha.
yellow for Y, which is why I chose those colors. So, and then go ahead and change that to black. So now we'll have something that'll contrast against the white of our mesh. Go ahead and hit play. There we go. That'll show up. Now, if we look in the center where we have all of our information we've got, we have a single normal, which is great. Here's where our problem comes in. If we look at our edges, one mesh has one normal, the other mesh has a different normal, and these are different. If this was calculating correctly, this normal should be the same for each mesh. There should be no difference. They should pop up and be in the same direction. And if we get into a corner, and I zoom in close enough that we can see it, we have 4 different normals being calculated for the 4 different patches, which is why we're seeing our seaming. So what we have to do is come up with a new way of calculating normals that is smart enough to know that, hey, we're not just calculating a single patch. There's information over here to go get. There's information up here and information here. So for this one vertex, granted, they are 4 different vertexes on 4 different patches, but the information that is stored here for calculating this normal should be calculated the same regardless of what patch it happens to be in. So we have the ability of calculating that information. It's just that Unity's recalculate normals method was never designed to handle this case. So we have to create our own method of doing it. And that is what we'll be doing in the next video.
Okay. Now we're going to be doing it in the next video, or we're going to be talking about it?
Yeah, we're going to talk about what we're going to do. And then we'll implement it in the video after that.
Okay. Fantastic. All right. Well, with that, that is going to wrap up this video. Thanks a lot.